All right. Good morning again. Especially to those who just joined us. Um, as I've already or as I told you guys yesterday that today is going to be a quick or an extensive, let's say an extensive a revision, right? Based on chapter 8, location strategies. So I believe that is the chapter that we should revisit. Probably there are some areas that a lot of you still do not understand, and this is an opportunity to ask questions, right? And yeah. Guys, please make sure that your microphone is off because I can hear some noise coming from your side.
Bam, 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 bam.
Siabonga Selby. Okay. Um, Perfect. So let me quickly. I've prepared some questions there that I would like us to go through them together. Um, I believe that you guys also going to participate because the questions that we're going to try to go through today are also they are structured in a way that you might be finding the same structure in the test. So there are, straightforward questions. You just need to know how to tackle them, and I believe you're going to pass the test. So let me quickly let me open the questions that I have prepared first. To actual, no, not actual. Journal. So I'm going to share my screen. Sound. All right. Yeah, I'll share my entire screen. So hopefully my screen is visible on your side so we can start. So there are just three questions, right, based on the three models from chapter 8, whereby we have break-even point analysis. So that is question 1. We have the center of gravity, that is question 2. And lastly, you have question 3, which is based on the factor rating analysis. So this is how we're going to summarize our revision. As I said, the transportation model, that one is not going to come. But if you also need extra questions, I think I posted some questions on Moodle for chapter 8. They are also part of the tutorial questions. And in the handout of that chapter or extra note for that chapter, you can also see at the end of the chapter. Let me show you quickly before we start. Come chapter 8. Lecture slide explaining from the exercises. I think it's this one here. So once you open this document here, or this file, you go straight to the end or at the bottom, toward the bottom of this document. You're going to have some exercises here that are talking about the center of gravity, and you also have the solution. You see, this is the question here, all right? And here you have the answers of that question. So you can easily practice using this just to get a deeper understanding of the concept, break-even analysis, factor rating analysis, and what? And the center of gravity. So we have some questions here that believe are going to help you a lot, and you also have the answers. So you can practice based on this. So sometimes you are requesting for more exercises, but you do have them in your hands. So just make sure that you use whatever that is available. All right, so let's come back to our business of the day. So question one, let's kickstart with question one. I'll give you guys something like 5 minutes so that you can reflect on it. And then we're going to try to sort it out together or solve it together. So please, you have 5 minutes. Just read the question and try to understand it from your perspective. And then we are going to um, solve it together. So we have 5 minutes at 10, 9, 9, that 9, around 9, 6 past, 6 past 9, we'll stop and then we try to solve it together. So read it, reflect on it, think about how you're going to do it, and then we're going to discuss the question. All right. Um, so question one says that mathematically identify the range over which each location is best. So you're going to analyze this scenario mathematically. So there is no need of creating or establishing the graph in order to analyze the scenario. So here the question is telling us to do so mathematical. So what we're going to do in this case here, first thing first, you have to um, write or establish the equations of the three locations. So that is the first step, right? And after of formulating the equations, the next step is now to find the crossover point. So crossover point or the break-even point. So once you find the break-even point, and obviously you're going to calculate the break-even point in rand, in unit first, and then after you calculate the break-even point in rand based on the break-even point in unit. So calculate the break-even point in unit after you calculate the break-even point in rand. So once you are done with that, now you can move on to creating the different intervals or ranges. So you find the ranges and you can now go and check which location is best based on a given range. So that's where you're going to conclude or respond to the question. So those are the steps, right, that you have to follow for any questions related to the break-even analysis. So let's start with the equation for let me write here A. So because A here is Alberton. So Alberton here we're gonna write the equation. So here it says 265,000 plus 435,000. So this is part of the fixed cost. And you also need to know that total cost is equal to the fixed cost plus the variable cost times by the volume. So that is the form that our equation is going to take. So A, the equation for Alberton is, so we're going to have 265,000. Let me just, don't want this to be in bold. 265,000 rand plus 435,000. This is the fixed cost plus the variable cost. So you have two variable costs here. You must edit a 2 again. So here is going to have 12 plus 18 times x, which is the how do you call this? The volume. So you just need to pull out your calculator. So that is 265 plus 435. Yeah, it's gonna give us the equation. So that is gonna give us 700,000 plus 12 plus 18. I think that is 30. Just double check there if I'm wrong. So B is Benoni. So Benoni here is still going to follow the same process. So you're gonna take oh, hold on. You're gonna take, okay, at this point, I really don't need to put range, not necessary. But if you want to put range, you can put the range sign. All right, so this is the fixed cost. So that is 247,000 plus 653,000 plus the the variable cost. Just copy and paste so that you can save time. So here, you can also remove this. There is no need. You can remove the sign also. All right, so 13 plus 7, I think that will give us 20. So 247,000 plus 653,000. That gives us 900,000. So 900,000 plus plus 20. 13 plus 7 is 20. 20x. So what is also important here, you see these numbers here are quite huge. And probably during the test, you're gonna have something like this, huge numbers. So when you are writing, probably, I don't know, the answer is 9,000 after doing your calculations. Just make sure that when you are writing, don't separate, right? Just write as I'm writing here. So we write if it's 900,000, if it's 1 million or whatever, just don't separate. So just write everything like I'm writing now. So you just follow the same thing. So the last equation here is for Cresta. So we also identify the fixed cost. The fixed cost, that is 295,000 plus 705,000 plus 7.5 plus 7.5 plus 7.5. 7 plus 7 is 14. So 14, 50 plus, that is 15. So here we have 15. 15x. So the final equation will be 295 plus 705. That is 1 million. 1 million should have 6 zeros. Yeah, that's 1 million plus 15x. All right, so we are done with the first step or stage 1. So the next step is now to calculate the break-even point, right? So let's say break-even point or crossover point. So this is what we're going to do next. So after formulating the equations, now we can calculate the break-even point. So here, what is going to happen here? We're going to start, you're going to find all the possible combinations here. So we're going to have A, so the break-even point between, let me just make it in a proper way. A and B. So that is Alberton and Benoni. So you have to calculate the crossover point there. So Between Alberton and Benoni, you identify the equation of Alberton. This is the equation, and equalize that if the equation from Benoni. So that is B, and now you have kind of calculations that you can do, or an entire equation that you can now solve for x. So x is the unknown value in this case. So we are looking for x. So I'm sure you guys are quite familiar with the manner in which this can be solved. You can use your different ways in order to solve this. Right. So here we're going to have just bringing all the numbers without the x one side and numbers with x on the other side. So here 20x minus 30x minus 20x, that is 10x, is equal. Now you're gonna have 900,000 minus 700,000. What is that? Is it 20,000 or 200,000? Let's just double check that so that we are sure. So that is 900 minus 700. So that gives us 200,000. So 200,000 divided by 10. So just remove 1 0 here, and that is going to be 20,000. So that gives us 20,000 unit. Right. However, in the test, for online answers, don't write the unit. You just write, if it's 20,000 units, you just write 20,000. So again, when you are writing 20,000, don't separate here. Don't provide a space there to show the separation between the digit or whatever. So just write it as it is, 20,000. All right. So even if the system is going to separate itself, it doesn't matter, but you just write it in that format. So this is the break-even point in unit. So this is the point where the coastline of Alberton will meet the coastline of Benoni. However, we also need to calculate, or what is the cost of producing 20,000 units. So that is where the break-even point in the unit comes in. So you just choose one of the equations here, the one that is going to facilitate or is going to be easier for you to do your calculations. So I go with this one here. So I'm going to substitute x with 20,000, and that gives me a total cost. I mean, in other words, you are looking for the total cost of producing 20,000 units. So that is the total cost for producing this amount here, right? And once you do that, you just take your calculator and do your calculation. So here we're gonna have 700,000 plus, open the bracket, 30 times 20,000. That is 1,300,000. So yeah, the total cost is 1,300,000. So again, if you are writing for filling in the blank for the test, you just write this portion here in case if this is the final answer. You just write this portion here. So obviously the unit will be excluded. So this is 1,300,000 that we have as the cost of producing 20,000 unit. Beautiful. So we are done with that one. We're gonna move on to the next crossover point. You're gonna have a combination between A and C because we are done with A and B. So here we're going to have A and C. And A here, the equation of A, just copy that, paste it here, is equal to the C equation. So just copy that also and paste it there and solve for X. What will be the value of X here? So I will just do this using the calculator. All right, so I'm gonna have 30 minus 15, that is 15x. So, and then I'll have 1 million minus 700,000. That is 30,000, 300,000, sorry, divided by 15. That is 20,000. So here, still gives me 20,000 units. That is the crossover point between Alberton and Cresta. All right. What is the cost at that point? So again, I'll choose any of the equations here, but since I've already chosen this one, let me show you that you can choose any. So let's go with this equation here for Cresta. So we're going to replace X with 20,000. So I take my calculator. Let me just put a different color here also. So that is 1 million plus, open the bracket, 15 times 20,000. Still give us 1 million. So let me just copy this and paste it here. So 1,300,000 rand. So that is the cost of producing 20,000 units. So the last crossover point will be now between B and C. So B versus C. All right, so the B equation here is this one. Copy that and paste, equals to C. This is the equation for C. Paste it. So again, you just need to solve for X. Find the value of X in this case. So the value of X here, okay, 20 minus 15, that is 5x. So mean that I'll be dividing by 5x. So I take hold on. Yeah, I'll be dividing by 5x. So that is going to be 1 million. 1 million minus 900,000. Divided by 5. 20,000. So that gives us 20,000 units again. So this is again is the crossover point the crossover point between in unit between Benoni and Cresta, or B and C. So we have to find the total cost at this point. So there are already some indications here that will lead you to probably abandon some calculations. In this case, you can see the crossover point is 20,000 in unit here, 20,000, here's 20,000. So obviously your cost of producing 20,000 unit will be the same across the three break-even point. But let's just do it for the sake of proving the point. So I copy this equation and I replace x with 20,000 again. You'll find out that the answer that we're going to get here will be the same as the previous one. So here we're gonna have 900,000 plus, open the bracket, 20 times 20,000. That is 1,300,000. So it's the same amount that is here. So that is already tells you that there are some interesting things that is happening with this analysis, right? So you can see all these break-even points are the same, whether it's the break-even point in unit or the break-even point in rent. So that already tells you that the three cost lines of these three locations are meeting at one point. And that one point only has these two coordinate. So the line below, or the coordinate in unit, is 20,000 unit, and the reflection from the cost side is 1,300,000. So that is one point. So all these points are meeting right then. So, but let's see how we are going to address it at the end. So so this is the second step or stage of the analysis. So the third stage is now to identify the intervals, right? The intervals based on your findings here. So we always start with 0, right? You rank the crossover point from the smallest amount, or from the lowest to the greatest. So we start with 0. So we're going to have an interval between 0 and 20,000 units. Between 0 and 20,000 units, and from 20,000 units to, let's put this already, from 20,000 units to infinity. Let me see if I can pull that sign from my previous symbols. Oh, okay, I got it there. All right, so here basically you have two intervals, and this is where you're going to check we check or select or identify or determine the best location, right? So let's use the first range. So let's call it range 1 or interval 1. So range range 1. Guys, just give me a second there. Seems that there are people who are disturbing me. They're making a bit of noise in front of the door there. All right. Let's call this one here is range 1. So range 1 here is from gonna have from 0 to 20,000 unit. All right. And obviously you're going to choose a number, right? Between 0 and 20,000. I mean, that number must be greater than 0, and that number must be less than 20,000, so that you keep it within that interval. So here we can decide to go with something like 10,000. Any number that you want, it must just be within the range. So 10,000. Now, we're going to take the 3 equations here, and we're going to substitute x with 10,000, and then calculate the cost. And from the cost, we will choose the smallest amount. Remember, the idea is to reduce the cost. That is where the location could be profitable to the company. Because if the cost is high, it's not favorable to for the company to expand its business activity to that location. So here is 10,000. So we're going to replace x here with 10,000. And here again, we're going to replace x with 10,000. And lastly, here we're going to replace x with 10,000. Beautiful stuff. So here, what is the cost? And here below also, what is the cost? And here, what is the cost? So just need to take your calculator. So 700,000 plus between brackets 30 times what times 10,000. So that is 1 million. So you have 1 million here. All right. The following one is 900,000 plus, open the bracket, 20 times 10,000. So that is 1,100,000. 1, 2, 3. Yeah, 1,100,000. C, that is 1 million plus, open the bracket, 15 times 10,000. So that is 1,150,000. 1,150,000. Beautiful stuff. So what are you gonna do here? You just go for the smallest amount. But if you check nicely here, the smallest amount here is 1 million. Therefore, location B, no, A, sorry, is the optimal one. Is the optimal one. So obviously we are under this range here, but if you're not under the range, you're supposed to specify the range. So that is the optimal location. So let me just highlight it. Location A. So for a volume between 0 and 20,000, location A is the optimal one. Now, range number 2. So it's still going to do the same thing. So here is going to be from 20,000 unit. Yes.
Someone had a question there.
Okay. Okay, I'm reading from the chat box here, but if you probably want to give us more details about your question, please feel free. Is it Fortune, if you feel like you want to give us more details about your question, please feel free to do so. What does the second question about? Which question are you referring to? Which question, Fortune? Because we are dealing here with question one. So now, if you are asking about question two, I think it's better you just wait until we reach there and then we deal with that one. Because now we still on question one. You said okay, about the 10,000 range. How did you come about? Okay, okay. I think I got your question now. All right. You're asking about hold on. 10,000. That's the 10,000 that I used here. So here you have range one. So range one is this one here, this range, and this is range two. So in order for you to determine the optimal location, right? The location with less cost, you have to choose a number here between 0 and 20,000. Between 0 and 20,000, yes. And that number must be greater than 0 and less than 20,000. So you choose any number. It must just be within this interval here. Any. You are not restricted. Any number that you feel comfortable that is going to help you or make your calculations easier. So go for it. So here I chose 10,000, right? No one told me or forced me to choose that. But the good thing here is that this 10,000 is within 0 and 20,000. Somebody else could have chosen probably 15,000, right? Another person could have chosen 5,000 or 1,000, right? So you are not restricted. You can choose any number of your choice, but it must be within the interval. If it's beyond that, your conclusion will be different. So that's why when I'm marking here for the online test, I do not mark the answers, these answers here, like this total cost that you calculate, because different student will come with different cost. So I won't be able to mark those answers. The only thing that I mark here is the conclusion, because if you choose a number within 0 and 20,000 and your calculations are also done correctly, your conclusion must be the same. There is no other way around. You must only find the same conclusion. For instance, if you decide to go with, let's say, 15,000 or 1,000, you will still find out that location A is the optimal location. So that's what I mark in the test. And your conclusion is final, right? So if you say location A is the optimal location or Alberton is the optimal location, you get the full marks. I hope that answers your question. But if not, you can drop some more details in the chat box there. And yeah, as I said, guys, you can stop me straight away if you have a question, because when I'm sharing, I won't be able to see. And yeah, just interrupt me at any point. So the next range here is range 2. And so range 2 here is from 20,000 up to infinity. So let me just copy that infinity sign there. All right. So again, you're going to do the same thing. Which amount are you gonna go for here? I'm gonna go with. So the amount must just be greater than 20,000. You can even choose 1 million, 2 million. If you want to choose 3 trillion, right, or billion, is up to you, as long as your calculations, that is going to make your calculations easier, right? So here we have 20,000. I can decide to go probably with 40,000, right? Can decide to go 40,000. And what do I need to do next? I just need to do my calculations. All right, let me just also highlight this. So here I'm going to change here, which you have 40,000. Obviously, let me delete all this because I don't know the correct answer yet. Here is 40,000. And here I'm going to have 40,000 too. Okay, so now I can do my calculations and then conclude. Right. It's all about providing the conclusion here. That is what is important at the end of the day. So, to my calculation, 700,000 plus, open the bracket, 30 times 40, 30 times 40,000. So that is 1.9. Okay. And the next equation is 900,000 plus 20 times 40,000. And that is 1,700,000. Okay. And the last one is 1 million plus 15 times 40,000. That's 1.6. So 1,600,000. Good. So again, we're going to choose the smallest amount. And I believe the smallest amount is this one here. So that means location C is the optimal optimal one, or has the lowest cost. All right. So you can see your analysis here is clear. If you are doing the analysis and then you come up and start saying, or location B or location A is the optimal one, you also need to be specific in terms of the range or the interval within which that location is the optimal one, because you need that information. You cannot just come and say location A is the best, within which interval, right? So you really need to make sure that when you're analyzing this, you have to provide all the information that are going to support your claim or your findings. Right. So that is what the question was asking us to do, because it said mathematically identify the range over which each location is best. So with what we have here, as I told you, let's go online also, just try to see how this whole scenario looks like from a graphical perspective or point of view. So I told you can go online and then look for, can search on Google, plot a graph online, and then you'll see those open source calculators for plotting graphs. I have already shown you guys how to do that. So straight away, I told you that this is the one that I like using. So what I'm gonna do here will be just taking the how do you call it? The equations, and then paste it in here. And take the other one. This is B. Just copy and paste it here. And also copy this one here and paste it right here. Beautiful stuff. So automatically, this calculator has plotted the cost lines for me. So what I need to do, just try to zoom out, or we can just come here, say fit all, right? And if you want to zoom it a little bit in order to see clearly what's going on. Now I come here and click, I want to look for, what is that point? Beautiful stuff. You can see all these lines. This question is quite interesting. You can see all this line, all these cost lines, A, B, C, all of them, they meet at this point here. And the coordinate of this point, right, at the crossover point is 20,000 and 1,300,000. And this is what we calculated here, whereby we only find the same amount for the crossover point in unit and the same amount for the crossover point in rent. And this is how the scenario looks like. And from between a volume of 0 to 20,000, this location here is the optimal one. And here this is the equation for location A. So this location is the optimal one from 0, right? From 0 to, or from 0 unit to 20,000 unit is this cost line here that is the optimal. The reason also being here, if you take any value within this range here, 20,000 and 0, you'll find that if you do a projection here of a number, any number, do a projection going up, that line going up is going to meet this cost line first before meeting other lines. So that is also one of the reasons why this line has the lowest cost, and therefore it's the optimal location. So on this side as well, the same thing. So from 0 to from 20,000 rand to infinity, this red line here is the optimal location, because any number that you choose from here, you do a projection, is going to meet this line first. Therefore, this line has the lowest cost. And this line here is location C, Cresta. So now, if you are asked, what what is the what is the um I mean, which location will be best for a volume of 20,000 unit, right? So you can see this is the crossover point of the three location. So therefore, you cannot just pick one location and say probably location A is the best or location C is the best. All of them are good here, because if the company now said, okay, we will be targeting a volume of 20,000 units per month or per week, I don't know. So that means the company will just decide which one they want to go with, because according to our analysis here, all the locations are optimum for a volume of 20,000. And that is also the crossover point between the three locations. I hope that makes sense, guys. Any questions on that? Okay, it's understandable. So what is saying is that for range 1, we select any number less than 20,000 but bigger than 0. Yeah, correct. That is what I'm referring to. But it must remain within the range, because you cannot be talking about a specific range and then you go and take a number that is outside of that range. So obviously your conclusion will be wrong, because you are not within the range. What is showing you that you are within the range is that number that you are going to take. It must be within that range. And you do your calculations properly, your conclusion will be the same across the board. All right. Guys, let's look at the second. I don't know how many minutes we still have. Okay, let's see what we can do. And if the time is up, I will share the questions with you. Guys can go and do them on your own. Probably next week. When are we meeting again? Next week. Yeah, next week where we're going to meet, we can quickly review or double check your answers, whether you got them right or wrong. Okay. So let's look at the second question. The second question here, this is the okay, it's fine. So the second question here says that a chain of home health care firms in Louisiana needs to locate a central office from which to conduct internal audits and other periodic reviews of its facilities. These facilities are scattered throughout the state as detailed in the following table. Each site, except for Wuma, will be visited 3 times each year by a team of workers who will drive from the central office to the site. Wuma will be visited 5 times a year. All right, so First question says compute the x coordinate, which represent a good central location for this office. B, compute the x coordinate, which represent a good central location for this office. Okay, just reflect on it. I'll just give you guys 2 minutes just to reflect on this scenario. Sorry guys, I'm really exhausted. Yeah, so let's reflect on this. Can I give you guys 2 minutes? Or let me give you 3 minutes. So at 10 o'clock or kickstart.
Sir,
Yes.
yeah, this question seems like we have to find two x coordinates. We don't have to find y. Why? You made a mistake there, I'm sure.
No, you still need to find, you only need to find one. But
Okay.
yeah, the details, I mean, everything that you need is provided. So you just need to calculate one based on what is given. So the idea here, anyway, we're gonna do that, but you have everything that you need in order to calculate just one.
Yes.
Mm. Oh,
Yeah,
hold on.
there's a question there's on
Oh, okay,
in the
okay.
chat. There is not a question. It's a
Oh, okay. Now I think there was also, you see B, there was a mistake there. It should be supposed to be Y, not X.
yeah. So I think there's someone who's saying something there on the comment section.
Oh, okay. Let me check that one. Thank you. Somebody saying that actually we can conclude easily using the graph. Yeah, normally in the workplace, we use the graph quickly, just plot everything, and then we can read whatever that is there. Can you see? But for us here, just to check your understanding, so that's why I use the calculations, because during the test you won't be having access to all this. So, but using the graph, you can just put your equation there and then you conclude, straightforward. Yeah, I agree. It says, please plug the theory scope for chapter 8. Oh, guys, I've already given the scope. Remember when I lecture, I give the scope at the same time. I say, guys, focus on this, focus on that. Probably this, we're gonna have a question on this. So yeah, those who attend, I'm sure they know what I'm talking about.
Yeah, so you see, just that the scope, when you're presenting the scope there at the front, you are too quick for some of us to be on the same page with you. So can you please?
Oh,
Yeah.
oh, okay, okay. Oh no, it's fine. The test is on the 21st, so we still have enough time to, to have some sessions, and then I can give you guys more details about the test.
Okay.
Yeah. Okay, so let's look at the questions so that because our time is running out. Okay, I will be just calculating one, and then the other one you guys can do it because it's the same thing as long as you have unpacked some of the hidden details. So what you need to understand here is, let me probably create another is it a column? Yeah, let me create another column here. How can I put it? Was not giving me the option to insert a column on the right. Yeah. All right. So what we can do is fine. So let's say, because what is not clearly given here is the volume. That is what is not clearly given, because in order for you to calculate the x coordinate and y coordinate, you need obviously the x coordinate itself for its location, the y coordinate of each location, and then you need also the volume that was transported to those locations. But here it's quite a different story. They are talking about the visit instead of the volume. This number of visits are in this case here considered as the volume. So if you write volume here, and it says here, this facility are scattered throughout the state as detailed in the following table. Each site except for Ouma, so this one here, except for this one, will be visited 3 times each year. So meaning that each site will be visited 3 times by a team of workers. We will drive from the central office to the site. Ouma will be visited 5 times. So here, the volume here will be 5, and the rest is 3, 3, 3, 3, 3, 3, and here 3. So this now you have the volume. So what you need to do, you just need to take we're calculating x, right? If you are calculating x, we can also do this quickly with Excel. Okay, I'm sure you guys you get the picture here. So because I just don't want to do this manually, so let's just do this with Excel. Anyway, in your test you have to do this manually. So just for the sake of us saving a bit of minutes there, I'll just paste this table here. Excel will do the calculations for us. Just make it a bit bigger so that you guys can see. All right, so here we have the volume. So what do we need to do? We just need to take if you are calculating x, right? If you are calculating x in this case, let's say x score, right? X scores. All right. So here we're gonna take 9.2 times 3 times the volume, 7.3 times 3, 7.8 times 5, and so on until the end, and then you sum up everything, and you have to divide that by the sum of the volume. So here the sum is what? Can just already calculate the total here. Let me just do this. Let me write here total. So if you take this amount here, you can also do this using your calculator. There is nothing wrong with it. Put here this amount here times the volume. So the volume here is 3, right? This is what we have, right? 9.2 times 3. And now we're going to have 7.3 times 3. So I'll just pull the Excel function here so that it can do the calculations for me. So it has done the calculations. If you just double check here, you can see here it takes 5.5 times 3 and it gives us that answer. So done. All right. So now what do we need to do? We need to calculate the sum here, right? And then we divide by the sum of the volume. The good thing if you are doing Excel, if you are using Excel, you can already see some of the answers. Because if you check here carefully, down here, it gives us the sum of the weight. So we already have the sum of the weight here, which is 26. So let me just use Excel also to have that written there. So sum. Guys, do you do EUC? You guys have a module called EUC, end user computing, or whatever, I don't know. Ladies and gentlemen, because I think this is what you're supposed to do with your lecturer, your EUC lecturer, end user computing. All right, so here we have the total. So now what you're going to do, you're going to take this total here, and this total is what? Is 144. You can already see the total here, right? 144. So just to make things into perspective, I'm going to do this. Right, so here I have a total of 144. Now, I'm going to take this 144 divided by 26. So it's also the same thing if you want to do it manually, guys. So here I'm just using Excel just to, make it faster. So if now, this will be now the total, right, of the X or the X coordinate that we are looking for. So the X coordinate of the center of gravity, so that is going to be is equal to, I take this amount divided by this one here. And that gives us 554. If you are taking two decimal places, if you are working with Excel, you can play around with the rounding off here. It gives us 44. So this is the X coordinate. So if you want to do it manually, because I'm sure some of you, I believe, are lost here. Let's just try to do it manually so that, so here is, let's just do it 9.2 times the volume here is 3 plus 7.3. What did I close? No, hold on. 9.2 times 3, the volume, plus 7.3 times 3 plus 7.8 times 5 plus 1.4 times 3 plus 2.8 times 3 plus 5.5 times 3 plus 5 times 3 plus 3.8 times 3. You can see, so it still gives us a total of 144 and divided by the sum of the volume, which is 26, right? So we still get the same amount. So 554 if you are taking 2 decimal places, right? So you can also do the same thing for the y coordinate. Just follow the same approach in order to get to the y coordinate. So once you calculate your x coordinate and your y coordinate, you are ready to go. So as I mentioned also during our lectures, saying that you won't be required to draft a graph, right? You just need to calculate the coordinate and that's it. But if you were having a physical test, we're going to draft and carefully locate the center of gravity. Right. Let's quickly no, I won't be able to, won't have time to deal with question 3, but I'm gonna just give you guys an overview of question 3 and then you will go and do it on your own. Probably if probably when we're going to meet, we can quickly catch up before we carry on with other items or of that day's agenda. So here you have, it's a question 3, say a location analysis for Cook Controls, a small manufacturer of parts for higher technology cable systems, has been narrowed down to 4 locations. Cook will need to train assemblers, testers, and robotics maintainers in local training centers. Lori Cook, the president, has asked each potential site to offer training programs, tax breaks, and other incentives. Their weights and the ratings for each location are shown in the following table. High scores represent favorable values. Right, so you have the table here, you have the factors. So this is an a question on the factor rating analysis. So here you have the weights are provided. Sorry, it's, if you see this dot here, it means 0. Like 0.15, 0.10, 0.30, right? So now you have to calculate, what is the question saying? It says compute the composite weighted average rating for each location. Which site would you choose? So which site do you think is optimal based on the analysis that you're going to do, or the findings of your analysis? Which location will be best? So obviously you're going to calculate the score of each location, right? So if you take here for Akron, for instance, you have to calculate the score for Akron. Take 0.15 multiplied by 30, right? Plus 0.10 multiplied by 95 plus 0.30 multiplied by 95 and up to the end, and then you find the total score. And you do the same for each of the locations here. And at the end, you're going to choose the highest, or the location with the highest score. And that will be your optimal solution, optimal location. That's why they say, which site would you choose? That will be your optimal site. And in the test, we're going to ask this question a little bit, we're going to break it down. I'll be probably asking you guys if you have a question on the location, on the factor rating analysis. I'll ask you to give me the score of for instance, Akron. Give me the score of Biloxi, the Grove Cottage, and Denver, right? You give me the scores, and there will be probably a question that will be asking you, which location do you think is the best? So meaning that you really need to remember the answers of each of the locations. From there, I'll provide you guys with the options. So Akron, Biloxi, Carthage, Denver, and there will be some other options. So it will be now up to you to choose the appropriate location based on your calculations or the way you answered the previous questions in order to choose the optimal location. So that's how I'm going to break down some of the questions in relation to the factor rating analysis. So what is interesting here in this question again is question C. Say, which would you reach the same conclusion if the weight for operating cost and labor cost were reversed? You compute as necessary and explain, right? So they are saying that what is it? Operating cost is what is operating cost? Here's operating cost here. And operating cost and labor cost is labor cost. So they are saying that would you reach the same conclusion if the two costs are reversed? So what does that mean when they say reversed? So that means, let me take this. That means the cost of labor, hold on. Would you reach the same conclusion if the weight, so the weight of these two factors are reversed? So that means the weight for labor cost is 10. So meaning that 10 will come here, and not 10, is 0.10. And 0.30 for operating cost will now come here. And now they are asking you, would you reach the same conclusion as in question B? So that is the question. So once you reversed the two weight, and you have to do the calculations again, starting from afresh, and then again you choose the location with the highest score. Is still that the same conclusion as in question B? So that is the question that you have to answer. So go and try it on your own. If you're not quite sure, please come back and let me know. Guys, let's take the attendance register. In the meantime, if you have questions, please feel free to ask. But that is what we really needed to discuss today. I think I have given you guys, I've equipped you with everything that is gonna come in the test. Oh, by the way, before we take, let me check if there are questions here. Okay, we don't have questions in the chat box, so we're good. So let's take the attendance register, and I'll see you guys next week. Let's just take this. Manserve. Guys, also in the meantime, think about the assignment, the kind of people that you may be willing to be in the group with, because I'm going to issue the assignment from the learning guide. It says that the assignment is supposed to be issued on the 26th of August, but I will issue it probably before that date. Yeah. All right, please sign the register. Once you're done, you can leave and I will see you when I see you.
Sir,
Yes.
can I ask, so Friday classes, you change them into tutorials, ne?
Yeah.
Oh, okay, thank you.
Yeah, Friday classes are now for you guys to enjoy with your tutor.
Uh-huh.
All right.
Sir,
Yes.
I wanted to ask something regarding the final exam date.
The final?
Exam date.
Okay.
So when I looked at my learner guides for the other modules, I saw that we share the same date with business management, which might cause trouble because it's theory versus theory.
Mm.
So I wanted to ask
Business management. Who's your lecturer?
Dr. Roberts, Mr. Roberts.
Mr. Robert, and he put it on the 31st.
Yeah, when I checked it, the date for the final
Assessment.
assessment is on the 24th of October, according to the learner guide.
Mm.
So the one for business also is also on the 24th, and it's theory, and also your module is theory. So I think it will be a huge problem.
Yeah, thank you. I don't know. Can you send me an email? Right? Send me an
Yes.
email and you just confirm the name of the lecturer. Just state what you are saying now via email, and then I will check, because remember, I'm the one who sets the date of our department. So I think there should be a mistake from Mr. Robert, because there is a day allocated to his module. So he's supposed to follow that date, but it's fine. Just send me an email and then I'll take that up. And please, the next session where we're going to meet, I don't know if you can remind me about this so that I can give you feedback if I have addressed it or not.
Yeah, I will surely remind you, sir.
Perfect. Thank you.
Sir,
Yes.
is there any chance you could provide us with previous question papers, or you have an idea of where we can get them?
It's fine. I'll give you guys with the question paper from last year.
Yeah, can you please share it on the... Where can you share it, sir?
I can share it on the WhatsApp group.
Yeah.
Just give me a bit of time there. I will do it when I'm a bit free, but I can share the question paper from last year with you guys.
Okay, so we might expect it when? Today, tomorrow, when?
Let's say tomorrow.
Okay.
Yeah.
No problem.
All right.
Sure. Should we remind you, or you will not forget?
Now you can always, in case, since I've said tomorrow, if you don't get it by tomorrow, you can even send me an email later on tomorrow, just to remind me.
Okay.
All right.
Thank you.
Okay. Cool, guys. Thank you, and I'll see you when I see you. I'm out.